customer-led network revolution project is how to actually operate and maintain and build a network in a way that helps facilitate the UK's transition to a low-carbon economy, particularly focusing on the electricity network part of that. What we're trying to do is make sure the network can accommodate the low-carbon technologies and renewable generations that people want to put onto the network. For instance, people putting solar panels on their roof has an impact on the network. As electric vehicles become more common, that'll have an impact on the network as well. So what we need to do is actually make sure that we can operate the network efficiently and flexibly, and that means taking advantage of the actual headroom that there is in the network, and real-time thermal rating has a part to play in that.
Today we're in Northumberland on one of our rural sites, which has been chosen specifically for the deployment of the real-time thermal rating equipment. We'll be putting several of these on. 4 of them over the last few days and some more in the summertime on the extra high voltage. This particular instalment is specifically geared up for high voltage overhead networks. We will be doing real-time thermal ratings on other devices as part of the project. We'll be looking at real-time thermal rating on transformers and underground cables as well.
In actually operating the network on a day-to-day basis, we actually have figures for what capacity we think the line is, how much current it can take. But in truth, the actual capacity of the line, how much current you can put through, does depend on the conditions, because they affect the temperature of the line itself and how much current it can carry. So what we've got here is a weather station that looks at the amount of sun falling on the line, it looks at the wind speed, which has a chilling effect, and it records that temperature, and it records the actual temperature of the line and the current going through the line as well. And we get all that data back, and then we can understand how weather affects the real capacity of the line.
We've given several companies the opportunity to air their wares basically. This one in particular, it's a prototype in essence, but it's been proven in Northern Ireland.
This is the weather station, which is a standard off-the-shelf weather station. This is the actual power line sensor as well. This is the FMC sensor, and it measures the current on the conductor via a CT here, a current transformer. This is the controller, and it's made up of an SNG, which is a sensor network gateway, and this is the device that captures the information via radio from the power line sensors itself and forwards it then by GPRS back to the server.
The data that they've had back from Northern Ireland has proven to be useful data. It's a tried and tested device, type of equipment, and it seems to be functioning admirably at the moment.
Every 5 minutes there would be a report sent back to a server with data from the power line sensors that you'll see installed on the conductor, with the temperature of the surface temperature of the conductor, the current that's flowing in the conductor, and all the weather parameters. All of those parameters are then analysed by the other teams in the project to assess what's the best approach for dynamically rating this type of circuit.
So one of the understandings upon which the project is conducted is that what we learn, what we experience, what we do, the results we have, aren't kept in-house within our own company just for our own benefit. Those are actually shared with other electricity distribution companies and electricity supply companies, so that they can actually learn from our experience, and whatever improvements we can make in the way we operate, then they'll be able to pick those up and use them too.
This is a small part of a much bigger thing. The need to get this information out, I think, is very important. It's the learning is what we're here for, and the RTTR being a small part of it, as well as other things as enhanced automatic voltage control, electrical storage. They're all going to come together to form a clearer picture so that we can build our future models and our plans for the future and our designs for the future on more real data that we have now.